For rotations, we're going to turn, and a lot of what we talk about in class is going 90 degrees or 180 degrees. And then we have clockwise. So a clock starts and it goes around. Or counterclockwise, so if a clock started going backwards, it would go like this, okay? So that's how you're going to turn your paper. So if you're going to go clockwise, I'm going to take the corner of my paper, and I'm turning my paper in my hand this way, and that was a 90-degree turn. So the corner that I had here is now the corner over here. So corner to corner is 90 degrees each time. So I did 90 degrees clockwise. If I turn my paper again, which is upside down, now that was a 180-degree turn clockwise. So if we go back the way it was, same thing. I'm going to take my paper over here, and if I turn this way, that's 90 degrees counterclockwise. Again, another 90 degrees counterclockwise. So we did a 180 degree. Okay? So you will see here that this is our coordinate notation for if we are turning points. So we can look at this and we know that if I'm going to do a 90-degree turn, X and Y are switching places. Not only are they switching places, but your X is becoming negative. Okay? 180 degrees is a little bit easier if we think about the notation-wise because it stays the same. It's X and Y. The only difference is whatever your X value was, it's a negative, and whatever your Y value is, it's a negative. But instead of thinking of it of a negative, negative is going to be opposite. So if I started with a point at 1, -2, and I'm going to do a 180-degree turn, and 180 degrees is upside down, so we don't have to put a direction with this one. So we don't have to do clockwise or counterclockwise because they're both upside down regardless. And it's going to be in the same spot. So when I use our notation here, our rule, it's negative of your X. So if it was positive, this is going to become a -1. But what happens if you take a negative of a negative? A negative of a negative becomes positive. So this is 2. So really, they just became opposite. Okay? So whenever you see the negative out front, these negatives are going to become opposite of what we had. Positive to negative, negative to positive. And then our 90-degree turns, we are going to flip our X and Y for a rule. Okay? So down here, for example 1, we have quadrilateral bird. So I'm going to write our letters B-I-R-D, and we have 5, 5. We have 5, 10. We have 0, -5. And we have 10, 5. So we're going to do a 90-degree clockwise rotation. So 90-degree clockwise, we have X, Y. We know that we got to switch, so it's Y, X, and it's the X that is negative because when we go clockwise, X is going to become your opposite. So I'm going to write my rule down here so we can use it. So if I have 5, 5, we're going to switch them. The Y value is going to become first, and then your X value of what it was, so it was 5, is going to become -5. So they're going to switch places, and your X becomes negative. So it's going to be a little bit easier to see here with your I coordinate point because we have different numbers now. We have 5 and 10. So since this is X and this is Y, Y gets written first, 10, and then your X is negative, so instead of a +5, I'm going to write a -5. We have R. We're going to write our Y value first. It's going to stay negative because remember the Y just gets rewritten. But then 0 is our neutral number. It's not positive or negative. So it's still just going to be 0. It's going to be in the same spot. And then here we have 10, 5. We're going to write our y value first, and then our x value is going to be written as opposite. So how does this work on a coordinate grid? Okay, so we have ABC, and we're going to do a 90-degree counterclockwise rotation. So counterclockwise means that we're going to start here, and we're going to go backwards to here. So this is 90 degrees. So if I take my paper, I have A, B, and C here. A is at 1, 2, 3, 1, so 3, 1. B is also over 3, 1, 2, 3, and it's 1, 2, 3, 4, so 3, 4. C is at 1, 1. So over here, we know that we have a counterclockwise is going to go x, y, and it's going to become negative y, x. So we're going to write our notation here. X, y is going to become negative y, x. And so we can write our new points here. Negative 1, 3. Negative 4, 3, and then negative 1, 1. Okay? Now, the reason that that works, and I'm going to show you why this works here in a second, is because we have our coordinate grid here. And if I take my paper and I rotate my paper, I just did a 90-degree counterclockwise turn. So we can kind of see this sideways here that C prime is going to be at negative 1, 1. So when I turned my paper 90 degrees, you guys can tell that C, if this is where my pre-image is going to be, I am at negative 1, 1. So without knowing the rule, you can always turn your paper and you can figure out these coordinate points, so we don't have to memorize a rule. So we can go from here, backwards 1, up 1, so negative 1, 1 is C. Negative 1, 1, 2, 3 is A, which is what I have written, negative 1, 3. 1, 2, 3, 4, so negative 4, 1, 2, 3. Negative 4, 3 is where we have B. So again, we can get these coordinate points just by rotating our paper and looking at the original shape, writing the coordinate points, and then we can turn our paper back the right way, and we can plot the points that we have written here, even if we didn't memorize this rule. So negative 1, 1 was C, so C prime. Negative 1, 3, so negative 1, 1, 2, 3. This is A. And negative 4, 3 is where we have B prime. So that's my shape if I go 90 degrees counterclockwise, and we can tell where this is at here is the same place as if I were to turn my paper. My original shape takes that place. I can write those coordinate points. Okay. So the last example that we have down here, we can do it either way. So I'm going to get my points by graphing this one and looking at the turn. So this one is LOVE, so quadrilateral love. And we're going to be at 2, 0, 6, 0, 3, negative 4, and 7, negative 7. So I'm going to plot all those first. So 1, 2, 0. 6, 0. 3, negative 4. So we have our shape here, and these are the original coordinate points that we graphed here. If I turn my paper 180 degrees, so 90 degrees, 180 degrees, this is where my new shape would be at. So we're gonna just kind of write our points up here. L is at 1, 2, so negative 2, 0. O is at 1, 2, 3, 4, 5, 6, negative 6, 0. V right here, 1, 2, 3, 1, 2, 3, 4. So V was at negative 3, 4. And E, 1, 2, 3, 4, 5, 6, 7. So negative 7, 1, 2, 3, 4, 5, 6, 7, positive 7. Okay, so I'm gonna turn my paper the right way. I'm gonna look at what I wrote upside down. I'm gonna rewrite it here. Negative 2, 0. Negative 6, 0. V was at negative 3, 4. And then E was at negative 7, positive 7. So you can tell by looking at these, more so the V and the E, that your X and your Y flipped. So X right here was positive, became negative, was negative here for Y, became positive. So we used the rule that it went from negatives to positives or positives to negatives, and so each X and Y flipped, which if you remember is the rule we talked about here. X and Y are going to become opposite of what they were, which is the example that we gave here. So we could have used our rule, and our rule would have worked, but also turning our paper worked, okay? So that just shows that either way, we can do either thing, and I'm just gonna plot these points so we can see what the shape looks like. So L prime, O prime, 2, 3, 4, 5. This is E prime, and then over 3F4. V prime, and we can tell if we connect our points. We have the same shape here, rotated 180 degrees. And that's how we do rotations.